everyone, welcome to your last lesson of Unit 4. Today we are discussing green Skittles, whether you like them or not. So apparently in 2013, Skittles changed the flavor from lime to sour apple. Big mistake. Mrs. Pendleton takes a small handful of 5 Skittles from a bin of 10,000 and gets all green. Oh, if 20% of the Skittles are green, what is the probability of this happening? So I want you to answer questions 1 through 4 on the worksheet. Then, so pause the video now to answer 1 through 4. Check the binomial conditions. Remember, we're going to take one Skittle out at a time. And so think about that when you get to number 1 and 2. And then we will pause or go over some rules, and then you can do the last questions. So pause the video now and do 1 through 4. All right, so here are the answers to 1 through 4. It's actually not a binomial setting because first we have the binary green or not green, which means the B, but it's sampling without replacement makes it not independent right now. And I didn't check the rest of the conditions because I stopped at the I once it wasn't binomial there. Okay, I do not want to study with anyone live for 6 hours. 6 out of that. All right, so for number 2, then we just assumed, since it was without replacement, that once I took one candy out, there was one less green, and one less candy overall. And so I multiplied all those together. Number 3, I used the binomial formula because we do have a sample size of 5 and the probability of success 0.2 if we ignore the independent condition. And then what I want you to notice, though, is if I use the formula when they're not independent and I use the binomial formula assuming that they are, I actually get almost the same answer. I think this one might have been like 319 or something like that, and I rounded it up to 32, and so they're very close, pretty much the same. And the reason why is because, this was a really large denominator, and decreasing it by 1 at a time didn't really make a difference. 2,000 out of 10,000 is 0.2, but 1999 out of 9999 is also pretty close to 0.2. So what that means is when your population is large enough, then, and your sample size is a small enough proportion of that, like I only did it 5 times, then we still meet the independent condition. And so we can say when sampling without replacement, the independent condition is met when our sample size is less than 10% of the population size. And so this is called, so if you're out of room here, if you can fit it on the side, the 10% condition. And so it says that, if n is less than 10% of the population, you're good, or if your population is greater than 10 times your sample size. Those say the same thing. So you'll see it written both ways. And so that's the case for this. If I check it over here, then I have, 5 is less than 10% of 10,000. So 5 is less than 1,000, and we're good to go. So that's how you check it, like I did in the purple. So if you look at number 5, or before you get to number 5, we're going to sample 100 Skittles, and we can use the 10% rule because 100 is less than 10% of 10,000. So make sure you write that down before you get to the rest. So now I want you to complete 5 through 8. So go ahead and pause the video and then complete 5 through 8. All right, so here we use binom CDF. So here is where I check the 10% condition again. And then I use binom CDF here because of the less than or equal to. And I got 0.0126. If you look at the histogram, you'll see it looks approximately normal. That's the shape. And so what we're going to do is just use the normal distribution to answer these questions. In order to use the normal distribution, we have to check the mean and standard deviation. And you know these formulas from your binomial notes. That's the mean and standard deviation of the binomial distribution formulas. So we just plug it in and get that. And then we can do normal stuff. So capital N, 20, comma 4. We want to know what's the probability that x is less than 11. So we find the z-score for 11. Then we get negative 2.25. Use table A, draw our standardized curve. And so this is something that we can do. Look how close they are, 0.0122 to 0.0126. Again, pretty close. And so a binomial distribution is approximately normal when we have n times p is at least 10 and n times 1 minus p is at least 10. And so if I check my work over here, then I have, n times p was 100 times 0.2, that equaled 20. That's at least 10. And 100 times 1 minus p. And so I would be able to use the normal curve and get really similar answers. This will be important to us in our next unit that we'll do after the break. And so you need to know it now, though. And you'll practice on the check your understanding. So go ahead and copy this down, pause the video to get it all on your paper, do the check your understanding, and then we'll come back to make sure you have all those answers. And just FYI, all three of these are saying the same thing. Okay, so let's see how you did on the check your understanding. For number 1, I checked the bins. It was independent because of the 10% condition. I used binomial CDF. And then we can also actually do this in the normal curve way. And so I checked the normal distribution condition and use the normal curve. In order to do that, I had to calculate the mean and standard deviation first. So I did. And I used all the same stuff we've learned before with the normal curve. And I got 0.0838, which is really close to the other answer. You're going to get them a little bit off for these problems, but they're always close enough, and either one is correct. But when your sample size is large enough such that the normal condition is met there, n times p is at least 10 and n times 1 minus p is at least 10, then many exam answer keys will use the normal curve to do it. And so you just have to know that that's why your answers might be a little bit different, especially when you're looking at multiple choice. All right, thank you so much. Check Canvas for what's next. Your Unit 4 test is coming up, so study for that. Have a great day. Thank you.